Anyway, we might as well get started. So let's, yeah, go ahead and dive in. Okay, we're being asked to find the number of ways to express n as the sum of some consecutive positive integers. So at least two consecutive positive integers. So basically, if we're talking about the number 9, the answer is going to be 2 because we could represent it as 2 plus 3 plus 4, or we could represent it as 4 plus 5. So there are a couple ways to do it. Whereas when we're talking about something like 8, we don't have any ways of doing that. We can't express 8 as the sum of 2 or more consecutive numbers. So, yeah, we'd return 0 in that case. All right, so this section is called, what is it called? Yeah, the Labyrinth of Nested Loops. And you can sort of see why with a problem like this. So like the sort of natural way I would say to approach this kind of problem would be to probably do a nested loop. So first of all, we'll say like, what do we want to call these? Basically ways of expressing n as a sum. You know, like how many ways can we express it as a sum? Let's call it how many ways. That's a fun variable name. Okay, great. Return how many ways. That's going to be the last thing. All right, so then where are we here? Okay, basically we want to do a nested for loop, or, you know, a nested loop. We happen to be using a for loop right now, but basically it's going to go something like this. So we want to have kind of like the start number to this and then the end number to it. So like for 2, 3, and 4, the start would be 2, the end would be 4. Okay, so we're gonna have start and end. Yeah. Maybe, yeah, I don't know, begin and end. Maybe that's better. I don't know. If anyone has a preference, let me know. We're not going to start at 0 because that wouldn't really help, right? If we were trying to express something as a sum of integers, then, well, 0 wouldn't make a difference. So we don't have to worry about that. So begin is 1. We want to keep this going. We'll talk about for how long in just a sec, but we'll get that set up for now, and then we'll get our other loop in here as well. So begin and then end. And, well, keep in mind, this has to be at least 2 elements long, right? So since it has to be at least 2 elements, that means let's start end as being basically begin plus 1, right? Because it has to be at least the next one over. Okay, cool. And then what do we want to do from here? I guess, yeah, we'll talk about that in just a sec as well. But within each loop, basically what we're doing is, and the reason we're setting up this nested for loop, I guess I haven't mentioned that yet, so let's talk about that. The reason we have the 2 for loops here is basically because we want to go through a situation where we're going to be like this, okay? We're going to say, let's say 9, for example, right? N is 9. That's the thing we wanted to all add up to. So first we'll start with 1. We'll say begin is 1. So if begin is 1, let's see what we could do. So we've got 1. Well, yeah, that's just 1. 1 plus 2. Well, that's going to be 3. And then add 3 to that. That's going to be 6. And like I'm just going to keep going with this until it's bigger, or until it's greater than or equal to 9. That's going to be the idea for this example anyway. Okay, so it's 10. So now this is too big. So we should stop. We will not be able to find, since this is already too big, we're not going to be able to get a better answer by adding more numbers onto it. So basically, we want to stop there. That's going to be this condition in here. We're going to stop as soon as we find that our sum, which, you know, I'm going to write in up here. Sum is going to be a sum of value 0 to begin with. And, you know, we're going to add it up the numbers from begin to end. And if sum ends up being equal to 9 at the end, then we'll increment how many ways. If it's not equal to 9, no, that's fine. We won't increment how many ways. Okay, so then let's get that in. Or actually, hold on. Before we go any further, so what's going to happen next? Well, we've got a number that's too big, so we're going to be done with this. We're going to, actually, let me just clear everything. Yeah, great. So now begin is going to get incremented up to 2. So it's starting at 2. 2 is too small. 2 plus 3, now that's going to be 5. That's still too small, so we'll add on 4. And that's going to give us 9. So that's no longer too small. It's exactly 9. It's what we're looking for. So not only will we stop the loop, we'll say, hey, that's good, you know, nice, good job. So we'll increment this. And then at the end, you know, we'll return how many ways that we have, how many we found in total. But the question, I guess, is what about this? You know, under what condition are we going to actually stop incrementing begin? Well, let's think about it. What would make most sense here? So it's starting at 1, and for something like this, basically 4 plus 5 is the best we can do. We probably wouldn't start it at 5 ever, because we have to have 2 numbers at least, right? So if we had 5 plus 6, that's already too big. That's 11. So we probably won't ever start it, won't begin at anything that's bigger than half the number. Okay, so for this part, we just want to say while begin is less than half the number. So that's going to be the idea. Okay, cool. And then for this one, what do we say? I forget. Oh yeah, it's that we were going to do this thing. Let sum be assigned the value 0. And we want to keep this going while sum is less than n, right? N's the number we're looking for, like the 9 in that first case. Okay, so then basically what are we doing in here? We're saying sum plus equals, oh, wait a minute, sum should start as begin, right? Yeah, and then sum plus equals end. Yeah, does that make sense? Hopefully. Anyway, at the end here we'll say if sum is the same as n, like exactly the same as n, then we're going to increment how many ways? Plus plus. Let's run that. Oh, okay. It's passing all the tests. That's nice to see. Let's make it official. Oh yeah. Very nice. Okay. What a pleasure to see that. Oh. And there we go. You can hear the air horns in the background celebrating this great victory. So yeah, we made it. Trainee 5. Congrats, everyone. We did it. Okay, great. So what do we want to do next? I guess I would say the first thing about this is that we're using a nested loop, right? So maybe there's a way we can avoid that. Yeah, I'm thinking there's probably a way we could avoid that. Yeah, okay. So there are two ways that I can sort of think of here. One of them is a bit, I guess I'll say, strange. So we might not do it that way. And then there's another way that's going to be kind of probably better. So yeah, I'm not sure which one we should do first. Well, let's see. We've got a rainbow sprinkle solution over here. We'll take a quick look at that. So let me just grab this. Okay, let's take a look at what's going on here. So ways starts at 0. That's, yeah, so far so good. We're on track here. Okay, yeah, less than n. Okay, sum. Well, it's very similar, right? Yeah, okay, you put it right in here. Ways plus plus. I put mine out there. Subtle difference. I think, yeah, this one, this would be the main difference, right? So like, I would say the only reason I prefer this one is because it's stopping it as early as possible. It's basically stopping it as soon as it knows that it won't find any like that there's no hope of finding the number beyond that. Okay, hold on a minute here. I was about to put a 1 on the end of this, but it's already got a number, so let's put the word nice. Okay, great. And let's cut that. We'll reset the code, paste it in, and we'll start over again. We'll do something a little bit different. Yeah, I had a particular strategy in mind for this one, but I kind of thought of a different thing just a minute ago. So maybe let's do the stuff that I had in mind, and then we'll go back and maybe we'll see if it's worth exploring that other idea I had. So, okay, let's try this. So the issue that I have with this over here is we've got a nested loop, right? If possible, I'd sort of like to avoid that. I'd like to be able to just sort of go through the numbers and not have to kind of backtrack, right? Or, well, okay. I'm using the term backtracking, and that technically has like a programming meaning, so I probably should avoid that. But what I mean is that we don't want to have to... I guess I'll just show you what I mean. Basically, it's this, okay? So we want to have a situation now where we're going to use kind of a two-pointer solution. So why don't we just sketch it out first? Let's do some drawing. Yeah. Okay. So basically, we'll have 9 again. We'll say 9 is the thing that we're trying to add up to. I'll just put my sum over here, and we're gonna have yeah, I guess we'll have like a start and end. So I don't know. I'm not exactly going to write it out like that. I'm just going to show you what I mean by this. So basically, the way we're going to start this is we're just going to add on numbers. So we'll start with 1. And since that's not big enough, we'll continue adding on numbers to the right of it. And you might be looking at this and saying, well, that doesn't really look like a two-pointer solution. You know, like you're just adding on numbers. Aren't you just incrementing this one? Well, what I didn't mention is that there's kind of a secret variable in here that's it's keeping track of the 1 over here. So this would be like our begin, and then this one over here would be like our end right now. Okay, so we added on 3. The sum is up to 6 now. Since that's still less than 9, we're going to keep going. We'll add on 4, and now that's going to be end, the 4 over here. So then we add that on, we get 10. That's too big, right? So since it's too big, instead of starting all over again, we're just going to say, all right, well, 10 was too big. Let's get rid of the smallest element here, and then we'll keep it going. We'll just delete that. We don't need to worry about starting with 2 and then like looping all the way up to this. We kind of already know that that we're probably close enough here. So basically, this is too big. We've subtracted the 1, and now begin is going to be the 2 over here. That's going to be the idea. So we're just subtracting begin and then incrementing it. And then over here, we've got, well, no longer 10. We subtracted 1. So we actually do have 9. So great. We've got 9. Now, when it's exactly 9, let's think about it. We know if we were to delete this one, then we'd get something that's going to be less than 9 for sure. So we know we need to, or yeah, well, okay. We're probably not just going to do that, right? If we're going to delete this, then we're also going to add on another one. So we'll put on the 5 and we'll say that that's going to be end. But also, since it's exactly 9, we know that when we add on this other one, definitely this one well, sorry, definitely when we add this one on, it's going to be too big. So we do also need to delete this one. So we're going to do both. Basically, if it's ever equal to 9, we'll both add on another number. Well, okay, I'll think about it this way. We'll increment end and we'll increment begin. And yeah, so we'll get that out of there. And so what are we looking at now? Well, we're looking at a very messy screen, but what do we have? 3 plus 4 plus 5. That's going to be too big, right? That's going to be, what is that, 7, 12? Yeah, 12. So since it's too big, we're going to delete this one over here. Begin is now going to be equal to 4, and that's going to give us 9. That's exactly it. So since it's 9, that means we're going to delete this one, and we're going to add on another one. That would give us 11. And you might be thinking, well, hold on, 0. Isn't that going too far? Well, don't worry about it, because check it out. Since the 11 is too big, it's going to say, all right, delete the 5, and now begin is equal to end, and we'll stop it there. Okay, so basically, as soon as begin and end are equal to each other, we're going to stop. That's going to be the idea. So let's try that. Okay, 4. Let begin be assigned the value of 1, and end will be assigned the value of 2. Yeah, and then sum is going to be 3, right? Yeah, I think. Anyway, we want to keep this going until begin is no longer less than end. As soon as they become equal to each other, we want this madness to stop. Why is this one not blue? That's kind of bugging me. Anyway, is a for loop even the right thing to do here? Maybe it's not. Maybe I won't. Yeah, I'm gonna not. Okay, so we'll use a while loop because I'm just thinking like the incrementing at the end is gonna be different depending on what we're looking at, right? Okay. And ATD is wondering, I wonder if reduce could be used for this. Yeah, maybe. The only thing is we're not really starting with an array, but I suppose we probably could, right? We could generate an array for it. Maybe we'll take a look at that in a minute, but for now, let's get these guys in here. So begin, end, and sum are going to be assigned the values of 1, 2, and 3 respectively. So we'll use a little destructuring assignment, everybody's favorite. And yeah, that's looking really nice. Oh, that's the thing I wasn't supposed to delete. Oh well, there we go. No, not Ned. All right, there we go. Great, great, great. So, what were we going to do here again? So sum is equal to 3. We basically want to say if the sum is equal to n, yeah, if the sum is equal to n, then we're going to increment begin and we're going to increment end. Both of those are going to get incremented. Otherwise, what are we going to do? We'll say if the sum is less than n, then begin is the one we're going to increment, right? No, end actually. Yeah. And if sum is greater than n, then begin gets incremented. Yeah, actually, wait a sec. There's another thing that's going to happen in all of these cases. So, yeah, I might as well just do it in these conditionals over here. So before we increment begin, before we add it to the next number, we want to actually remove it from the sum. So we want to do like a sum minus equals begin. Yeah, important to do that before we increment it also. Whereas for end, yeah, I guess same thing. Or, oh, actually, wait. So end is 2. 2 has already been added on. So the next one we would want to add on would be 3. So yeah, we will increment end first, and then we'll say sum plus equals end. And then for this one over here, we want to do this, I guess. We'll put it in here because, or wait. Yeah, okay, hold on. It's actually the reverse of that. So we want to do end plus plus. We want to increase end. And then we want to increase begin after that. But in between the two, basically we're doing this, right? We're saying sum plus equals end, but then also sum minus equals begin. And then, yeah, incrementing from there. Okay, so basically the idea here is that we could probably do both of these in one step, right? We're adding end, subtracting begin. We could probably just do something like this. Sum plus equals end minus begin. Okay, cool. And I forgot to do this. How many ways? 0. So if we actually ended up getting this situation, how many ways plus plus? Cool. And then we'll return that at the end. Okay. Yeah, great. It's working. Nice stuff. So I think, let's just make sure it passes the hidden test. Great. Okay, so I think that's a little better. I think I like this one a lot better, actually. We don't actually have a nested loop here. We're just looking at a single loop, and what we do with our numbers just sort of depends on how our sum compares to our destination, our target number over here, n. So that's kind of neat. I think that's a good example of a two-pointer strategy. Yeah, I'm pretty sure. I could be totally off base with that, but I'm pretty sure this is a classic example of a two-pointer strategy. Anyway, okay, so was there another way I wanted to do this? Well, okay, here's the issue. I'm sort of wondering, because there's a formula for this, right? Okay. Yeah, okay, so that would technically be an alternative that we could use. It's kind of, I don't know, it's not great, but we might as well talk about it for just a sec. So I think we've talked about arithmetic sequences before on the channel, right? I'm pretty sure. Pretty sure we've talked about arithmetic sequences. But if not, let's just talk about them now. So we've got n, and it's a sequence, so I'll say t at n. Okay, and basically this sequence is going to be one that it starts, so if n is 0, let's say, should we start at 0? Yeah, okay, we'll start at 0. Wait, start at 1. Yeah. Okay, so the first term is going to be called a, and the difference between each of our terms is going to be called d. Okay, so a, I guess, because it's the first letter of the alphabet, and then d for difference. So then when we want to get to the third one, it's like a plus d, in other words, a plus 2d. We're just adding on the same thing each time, right? So like, just to give you a quick example for what this might look like, let's say we were talking about a sequence that, what's a good color? Yeah, this one right here. Let's say we're talking about a sequence that starts at 7, and the common difference between each term is going to be 3. Okay, so for this, we'll start with 7, we add 3, it's 10. We add 3, it's 13. We add 3, it's 16. We just keep it going like that, right? So you notice that's basically what we're doing over here. So we could also just sort of jump to one of these. Like for example, for 4 over here, let's say we didn't want to calculate all the previous ones. Well, we have a plus 3d now. So if a is 7 and d is 3, 3 times 3 is 9, plus 7, 16. Well, yeah, that's what we got, 16. Okay, good. So that sort of makes sense. That's basically our general formula. Or, okay, let me make it even more general, just a sec. Here, we'll say if this actually is the term n, then we'll say t at n is going to be assigned the value, or it's going to be equal to a plus some number times d. Well, this number right here is always just 1 less than whatever n is, right? So if n is 3, this number is 2. If n is 4, this number is 3. So it's n minus 1. And we're multiplying that by d, and there we go. So that's going to be our formula. That's going to give us our any term of an arithmetic sequence. But we're not really talking about an arithmetic sequence here because we're adding all these things up. We're talking about an arithmetic series. So because it's a series, we need to add up all of the terms. Okay, so, whoa, what just happened? Okay, there we go. Accidentally removed the tab from the window, but we're back. We're all good now. Good, nice job. Okay, so let's take a look at this. Let's talk about like how we can sort of visualize this. So what we're gonna have is our sequence. That's a. It's like our first term, and we're gonna have some number of terms after that. Whoa. They're not meant to overlap like that, but oh well. Anyway, how many terms are we going to have? We'll say n, I guess. Yeah, n many terms. So however many you want. It could be 1, 2, 3. It's up to you. This part over here, this is going to be a. All right, it's the first term, or yeah, t1 kind of thing. And then this part over here, this is going to be our last term. So this is going to be t at n. I think, right? Because if there are 4 of these, this would be 1, 2, 3, 4. Yeah, and n would be 4. So this would be t at 4. Well, we know what t at 4 would be, or what t at n would be just in general. It would be a plus n minus 1 times d, like we just saw upstairs. So, yeah, there it was. All right, anyway, what we want to do with this is we kind of want to use that Carl Gauss trick that we've seen before, where we do something like this. So we basically take a copy of this shape, this kind of like set of stairs shape. We want to take a second copy of that, flip it around, and now it kind of makes this rectangle, right? So what are the dimensions of this rectangle? Well, it's going to be a plus a plus n minus 1 times d, and then the other dimension is going to be n. So if we wanted the area of this thing, in other words, the sum of all the terms in our sequence here, basically it's going to be the following. It's going to be half of the area of this rectangle. We know the area of this rectangle, well, here, I'll say s at n, s for sum, and it's a capital. It's going to be equal to this. We know that there's going to be a 1/2 right off the bat because it's only half of this thing. Okay, and then it's going to be n, so one dimension here, n. That's about n. That's better. Okay, so n times this dimension over here, which was a plus n minus 1 times d. In other words, 2a, because a plus a, plus n minus 1 times d. Okay, so that's a formula we can use. It could be also written like, put the n up here. It's up to you. It's your call. Whatever you prefer. Anyway, the point is we can sort of use this formula, right? We can use it to calculate our sums. So here, let me grab this one again and put a distinctive word at the end of that one. Make sure it doesn't accidentally get called. We'll paste that in. We'll get rid of the nice because I don't think this is going to be very nice. But here's what we'll do. So we've got begin over here, and then we've got end. I guess that's not exactly what we want, right? Instead of end, we sort of want like here. Let's make this one A, just to sort of match the terminology that we had over there at the other place. We're not going to need this thing. We're not going to need sum. Instead, we're just going to change these. So this will be D. And, whoops, okay, I'm changing stuff I probably shouldn't be. This is D. What should D start as? Well, it's the common difference, right? So wait a minute. The common difference here is 1, though. Isn't that, like, necessarily true? Yeah, the common difference here is going to be 1 for each of these things. So we could simplify the formula. So we could say s at n is going to be n divided by 2 times just 2a plus n minus 1, I guess. Right? Does that make sense? Because we know it's going to be 1. We know that d is 1 here. Like, yeah, they're consecutive. They have to be consecutive. Okay. Okay, yeah. So we have this now. And we basically want to know, yeah, n is going to be like the number of terms. So I guess that's more what we want here, n, the number of terms. Okay, so if we want to do this, then n is going to start at 2, because we can't have just one term. And we want to keep this going until what? What makes most sense here? Well, I guess, yeah, just looking at this, like for the guaranteed constraints, we could probably use that, but maybe there's a way we could do this without getting into the guaranteed constraints. Oh, and I already have an n. It's this up here. Let's rename this one. We'll call it num. Yeah, cool. And then, okay, we don't want that, and we don't want that either. We're just going to do something inside the loop, and that's going to be it. But how long does this loop go on for? We should probably figure that out. Well, hold on a minute. Before we do, let's just say something like this. So const sum is going to be assigned the value of, what was it? It was n divided by 2 multiplied by 2 times a plus n minus 1, I think, right? So that's our sum. And we'll just say if sum is num, then how many ways is going to get incremented. Okay, cool. So then how long do we want to allow that to go on for? Well, let's see. Yeah, because like we sort of need to know. Okay, the reason I'm thinking about this so much is because we're only defining sum inside of here now, right? Whereas before we were using sum to determine if we'd gone too far or not. So what I'm actually going to do for now is I'm just going to say, well, n is less than 8. I don't know. Because let's think about it. If it was 8, then 8 plus 9 is going to be 17, which could happen, I guess. Let's make it 10. Or 12. Yeah, 13. There we go. We'll make it 13. Everybody's happy. Great. So... Oh, wait. Sorry, I was thinking that was going to be the number that we'd start with. And I was thinking we'd have to do, like, yeah, 13 plus 14 is going to be bigger than 25. But no, n is the number of terms that we're going to have. So, yeah, we can limit this a lot further than that. Because, like, how many terms could we have that add up to something less than 25? So, like, I guess we're just thinking about triangular numbers here. So, like, yeah, 10... 15, 21, what are we up to? Okay, let's write this out. Okay, so this is going to be n over here, and this is going to be the sum over here. So 1, 2, 3, 4, 5, 6, and I don't mean n, I mean like num or something like, yeah, anyway, the point is, so we're adding these up, we get 1 plus 2, we get 3, plus 3, we get 6, plus 4, we get 10, plus 5, we get 15, plus 6, we get 21, plus 7 would be 28, that's too big. So that means we can't have 7 terms. Okay. So, because of that, n is going to be less than 7. There we go. Great. Let's try that. Oh. N's not defined. Line 4. Oh yeah, n's not defined. Okay. Yeah, I guess that's that should be num divided by 2. Great. Let's run that. Awesome, awesome. Okay. Yeah, that was confusing because I was like, am I not defining n right there? But yeah, okay. I'm glad I've finally looked at the line number there. That helps. So let that be a lesson to us all, I guess. Anyway, okay, great. So that's working. I don't think this is better or even very good. I think this is probably worse than just about anything we've done. I think this is probably the worst one we've done. Yeah, I think this is the best one over here. Just time complexity wise, I think this would be closer to linear, whereas something like this would be probably quadratic, and same with this one over here. So that's probably preferable. I don't know, for the size of the numbers here, I don't know if it would even make like a measurable difference. So it's up to you, I guess. If anyone has like a particular preference here, I'd say go with that. But yeah, I think that's going to be it for this one. Let's get out of here.